This video covers Lesson 9-1 for Secondary 1 Math, Congruence. Warm-up 9-1. We want to fill in the blank for 1, 2, and 3 of the angle that would be congruent to the angle A, angle B, or angle R. That's what this symbol means here. This symbol means congruent, meaning it has the same shape and size. So angle A is congruent. If we look over on these figures, angle A is here with one arc. So we're going to look in the other triangle for that one arc, and that would be angle I. So we're going to write angle I in the blank. Number 2, angle B is congruent to what angle? Well, angle B has two arcs, and there are two arcs for angle T. So this would be angle T. Number 3, angle R is congruent to what angle? Well, angle R has three arcs across, and so does angle C. So angle R and angle C are congruent. So we're going to write angle C. 4 through 6. Now note, order matters, the order that I write these. So number 4, we have the segment AB is congruent to what? If we look up at the two triangles, we'll notice that AB has two tick marks on it. So looking at the other triangle, there's I and T that has two tick marks. Now we've got to determine the order that we write these. Do we go IT or TI? In number 1, we stated that angle A is congruent to angle I. So wherever A is, we're going to put I. So A came first in our statement, so we're going to go I, T, and put the bar above it. So the segment IT. Number 5, we have the segment IR. So IR is here with one tick mark. The one tick mark on the other triangle goes from A to C. Remember, I and A have to be in the same location. So it would be A, C. So segment IR is congruent to segment AC. Number 6, segment RT is congruent to what? Well, RT has three tick marks on it, and the segment CB has three tick marks. And R, if we look up at number 3, is congruent to angle C, so we're going to put C first and then B, because B corresponds to T. So segment RT is congruent to segment CB. Number 7, if the measurement of angle A is 80 degrees and the measurement of angle B is 45 degrees, then the measurement of angle C is what? So we know this is a triangle, and a sum of the angles in a triangle is 180 degrees. So if we take 180 degrees, we subtract 80 for angle A, and then we subtract 45 more for angle B, we'll find the measurement of angle C. So 180 minus 80 is 100, minus 45 would give us 55 degrees. Number 8. If RT is 24 millimeters, then BC equals what? Well, let's see. RT is congruent to CB or BC, that's the same segment, so it would be the same length, which means it's 24 millimeters. Remember, congruent means the same shape and size, so they're both line segments and they have the same length. Number 9, triangle ABC is congruent to triangle what? Now, order matters. That's an important thing to note here. Order matters. So what angle is congruent to angle A? If we look at number 1, it's I. So we're going to place I first, so triangle I. And B is congruent and corresponds to angle T, so I, T, and then the last one would be R, which corresponds with C. So triangle ABC is congruent to triangle ITR. Lesson 9-1, Congruence. So here are a few terms that we need to consider. The first one, congruent. That means that two figures have exactly the same shape and the same size. So like was discussed earlier with the line segments, they're both line segments, that's the same shape. Size would be their length, making sure that they're the same length. An angle would have the angle measurement being the same, meaning the same size. They're both angles, but the same size. Okay, the second term, congruent polygons. Two polygons are congruent if, and only if, this means it's the only case, their corresponding parts are congruent. So if all of the corresponding angles are congruent and all of the sides are congruent, then the polygons are congruent. And if we take a look at these two triangles that we had in the warm-up, these are polygons. They're specifically triangles, but they're types of polygons. And because corresponding angles are congruent and corresponding sides are congruent, the triangles are congruent. All right. The third term, congruent statement. This states which angles and sides are congruent. That's what it does. Corresponding angles are angles that are in the same position and may have the same measure. Notice it said may have the same measure. There are situations where we could have triangles with corresponding angles that are not the same measurement. Okay. Corresponding parts. So corresponding parts are just the angles, the sides, the vertices that are in the same position in congruent figures. Corresponding sides are sides that are in the same position and may have the same measurement. So a few things that we need to recall from our previous math classes are that the sum of the angles of a triangle is 180 degrees. Also that the sum of the angles of a quadrilateral is 360 degrees. Now we're going to use this information along with these definitions, and we're going to talk about congruent figures. So number one, given a congruent statement, identify all the congruent corresponding parts. So what's really nice about a congruent statement is it states that the shapes are congruent. So all the corresponding parts are also congruent. So that would be angles, and that would be segments or sides of the shape. So the nice thing is when we write these congruent statements, the order matters, as we saw in the warm-up, which means that the order tells us what parts are congruent. So the first letter in each of these is A and M. So those two angles are congruent. And we'd write that as angle A is congruent to angle M. And then we'd go to the next two, which would be angle B is congruent to angle N. And then the third one, angle C is congruent to angle P. Now that we have the three angles, we've used all the letters, we're going to start doing segments, which require two letters. So our first one would be AB, which are the first two letters in the statement. So triangle ABC. So that would be congruent to the first two letters in the statement, triangle MNP. So that would be segment MN. Then we have BC, would be the middle and the last. So segment BC, make sure you have the line above it, is congruent to segment NP. And then the last one would be the first and last. So AC, segment AC, is congruent to segment MP. Okay, number two, we have the quadrilateral EFGH is congruent to the quadrilateral WXYZ. So again, we're just going to go through in order. The first one in each part of our congruent statement, each quadrilateral, then the second, then the third, then the fourth, and that will give us all of our angles. So the first ones, we have angle E is congruent to angle W. Then we have angle F is congruent to the second one in our second quadrilateral, which is angle X. Then we have angle G is congruent to angle Y. And angle H would be congruent to angle Z. Now that we have all of the congruent corresponding angles, we're going to do the congruent corresponding segments. So we'll take the first two letters in each. So we'll have EF, or segment EF, is congruent to segment WX. Then the next two, so FG, second and third, would be congruent to, segment FG would be congruent to segment XY. Then we have segment GH, so the last two, would be congruent to segment YZ. And then the last one, we'll take the first and the last vertices. So EH, segment EH, would be congruent to segment WZ. Now, remember, order does matter, but if I were to write one of these the opposite way, for example, the first one, right here, if I were to write this differently, I could write it as the segment FE is congruent to the segment XW. And if I switch the one, I have to switch the other. They have to be in the same order based on their congruent corresponding part. Okay, so number 3 and 4. We want to show that the polygons are congruent by identifying all the congruent corresponding parts. Then we're going to write a congruent statement. So we're doing kind of what we did above without the congruent statement. We're doing it from the triangles. This is more like our warm-up. So the first thing we're going to do is identify one of these angles. So let's start out here with D. So I'm going to say angle D is congruent to angle, and now I've got to identify which one is the same as D. So we're looking for just a plane arc, which is J. So angle J. Then angle E is congruent to, that's the right angle, which is angle H in the other triangle. Then we have angle F is congruent to angle, that's the last one, which would be G. And you notice that they have an arc with a little tick mark in there, showing that they are congruent. Now that we have a list of all the congruent corresponding angles, we're going to look at the segments or side lengths. So working around the triangles in order, we can start out with the side length DE. So we write segment DE with the bar above it is congruent to, and then that would be from J to H. So JH. Then we work our way to the next one, E to F. So segment EF is congruent to segment HG. And then the last one, we have segment DF is congruent to segment JG. These are all of our congruent corresponding parts. So now we just need to write our congruent statement for the figures. Since we have a triangles that are congruent, we're going to use a triangle. And then we're going to go right down the order in the angles. So triangle DEF is congruent to triangle JHG, because remember, order matters, so I have to go in that order. Okay, so now we're going to do the same thing on number 4, but in this case we have a quadrilateral, a four-sided figure. So I just have to have 4 sets of congruent angles, 4 sets of congruent segments, and then my congruent statement for the quadrilateral. So I start out with the angles, and I'm just going to pick one. I'm just going to pick angle A. I'm going to say that angle A is congruent to. Now I'm looking for the double arc, and that double arc is on angle Y in the other quadrilateral. Then I make my way around. So now angle B is congruent to angle, this one has 4Z. And then I have angle C is congruent to angle W. And then angle D is congruent to angle X. Now we're going to do the segments. So I'm going to start again just with AB and make my way around. It has 2 tick marks. YZ also has 2 tick marks. So segment AB is congruent to segment YZ. And then I have the 4, so I'm just making my way around the shape. That's going to help me keep it in order, make sure I get each one. So I have segment BC is congruent to segment ZW. And then we have segment CD is congruent to segment WX. And then our last one, segment DA, and you could do AD, that's fine, is congruent to segment XY. Now, if I switch DA to AD, then I'd have to do YX instead of XY. Now, all we got to do is write our congruent statement. And here we're not going to use a square, even though it's a quadrilateral. We actually don't use a shape. And so they just list off the vertices all the way around. And so we'll write A, B, C, D is congruent to Y, Z, W, X. Now you might ask, wait, why aren't the vertices in the second figure in alphabetical order too? Well, the reason is that they have to be in the same place as the corresponding congruent part. So if I go A, B, C, D, it has to go Y, Z, W, X. Okay, number 5. In the figure, triangle LMN is congruent to triangle PQR. So they're telling us that they're congruent. So that means that all the corresponding parts are also congruent. Now we want to find the value of X in number 5. So first we're going to identify where X is in our shape. And it looks like X is part of the angle measurement of N. So looking over at our statement, N is in the same position as R. So angle N and angle R are congruent corresponding angles. And we know that R has a measurement of 57 degrees, so we can write an equation. 57 is equal to 11x's plus 13, because the angle measurement is the same. Then we would subtract the 13 from both sides to solve our equation for x, which gives us 44 is equal to 11x's. Then we would divide by 11, and we find that x is equal to 4. Number 6, find y. Y is part of the expression giving the length from L to M. When we look back over to our statement, LM is in the same position as PQ. So PQ is going to have the same length. It also has a y, which is nice. And we can set up an equation by setting these equal to each other, because congruent corresponding parts have the same length. So we can write 3y plus 4 equals negative 5y's plus 16. So then we could add 5y's to both sides of our equation, which would give us that 8y's plus 4 is equal to 16. Subtract 4, I have to move my work over here. We get 8y's is equal to 12. Divide it by 8, and we get that y is equal to 1.5. Number 7, find LM, which means find the length of the line segment LM, which we know y, so we can substitute it into the expression that tells us the length. So we're going to go 3 times 1.5, which is y, plus 4. Well, 3 times 1.5 is going to give us 4.5. Plus 4 is 8.5. So the length of LM is 8.5 units, whatever those units are. Okay. In the figure, the two triangles are congruent. Triangle ABC is congruent to triangle EDC. So number 8, we want to find X. So notice we have angle B here with one arc, and it has a value for X. Okay. We also note that angle A has one arc, and so that would be the same value. So I'm going to write for angle A, this is 5 times X degrees. Well, we also can use our congruent statement. We know that angle B is congruent to angle D. So angle D is also of the measurement 5x degrees. And angle E is congruent to angle A, which was congruent to angle B, so this is also 5 times x degrees. And we know the third angle in triangle EDC is 35 degrees. So we could say that 35 plus 5x's plus 5x's would be equal to 180 degrees, because the sum of the angles in a triangle add up to 180 degrees. So now if we combine our like terms, so the 5x's, we get 35 plus 10x's is equal to 180. Then subtract the 35 from both sides, and we get 145 is equal to 10x's. And then we can divide it by 10, and we get that x, I have to write to the left here, is equal to 14.5. Note, we're not putting any degrees here. It is just a value, not an angle measurement. So x equals 14.5. All right, number 9. We want to find the value of y. Well, here y is in the same position as the 35 degrees. Note that angle C is congruent to angle C in those triangles. And notice they're in the triangles. So angle C and angle C are the same. We could also think of them as vertical angles. And since they're congruent, y is equal to 35. Again, not degrees, because we're not talking about the angle measurement. We're talking about the value of y. This concludes the video lesson of 9-1 for Secondary 1 Math, Congruence.